Assalamu alaikum wa rahmatullahi wa barakatuh. Okay, it's a very good day today. It's Sunday, and I am back again with a very interesting physics question. Okay, the question is taken from a JEE advanced problem, and the question seems to be very interesting. And I am going to explain the solution, how it comes up. I have solved it for you. I'm going to explain it for you how it has come up. So let us first see the question which is there in the my screen. Okay. So here you can see the question. The question is about a flat plate which is moving normal to the plane under a gas, under the action of a or through a gas. The plate, okay, the flat plate moves through a gas under the action of a constant force F. The gas is kept at very low pressure. The speed of the plate V is much less than the average speed U of the gas molecules. So V जो है ये speed of the plate है. V is the speed of the plate and U is the average speed of the gas molecules. And this flat plate is being acted by constant force F. Okay, so we have to show the pressure difference between the leading and the trailing phases of the plate is proportional to U into V. So it's a JEE advanced problem. Okay, so we have to show this. I have written the solution, so let me begin. Okay, so you can see before I solve this problem, I have assumed certain things about this problem. Okay, so you can see V here is the speed of the plate. Okay, and we are assuming that the plate is moving towards the left. Okay, later on you are going to see that I have assumed even the sign conventions. Okay, where the left side is taken to be negative and the right side is taken to be positive. U is the average speed of the gas molecules, and it is given that U is much greater than V. Okay, and then you have N, which is the lumbar density of gas molecules. Okay, that means molecules per unit volume, and we have done a very simple assumption, that is half of the molecules move towards the left and the half of the molecules move towards the right. Otherwise, if we don't take this assumption, then our problem will be very difficult. Then M is the mass of one gas molecule, and A is the area of the plate face. Okay, now just to make things simpler, I have drawn a diagram. Okay, this is the diagram that you have. Say this is the plate and the plate is moving towards the left. So the plate which is moving towards the left, this side of this face of the plate is the leading face and the opposite side is the trailing face. So I have told the leading face to be the front face and the trailing face to be the back face. So the plate has an area A, and you can see the gas molecules with an average velocity U are hitting this plate from both the sides, from the front as well as from the back face, and this plate has a velocity V which is towards the left side. Okay, so that is what we have. Now we have done some kind of calculations, and then we'll see. You can see the calculation. The calculation is like this: the positive direction is taken to be the right direction. Sorry, I hope it is in the screen. The positive direction is taken to be the right side. So what is the velocity of the plate? Since the plate is moving towards the left, the velocity of the plate has to be minus V. Okay, and now we'll try to find out the change in momentum of the front as well as the back face. So for the front face, the ground frame velocity is before collision. Before collision, you see, just hold on. See, this we are calculating for the front face. For the front face before collision, just hold on. Yes, now it's okay. For the front face, the molecules were going towards the right side. So if the molecule is going to the right side, the velocity has to be positive, and the plate as usual is moving towards the left. That is why the velocity of the plate has to be negative. So what is the relative velocity before collision? The relative velocity before collision is velocity of the molecule minus velocity of the, that comes out to be U plus V. I hope you got it. Okay. That is positive, meaning that from the plate's point of view, the molecule is approaching it. You see, the molecule is approaching the plate. That is why we have taken it to be positive. Now, step B, what happens? See, the molecule comes, rushes towards the plate, hits it, and then reverses its direction. The moment it reverses its direction, the relative velocity after collision should be negative of this. Right, this is positive, and after collision it goes and hits. So the relative velocity before hitting is this U plus V, and relative velocity after collision is it goes away, then it has to be minus of U plus V. Okay, so therefore what is the momentum of the molecule which is delivered to the plate? Okay, then that should be what? Before collision, the relative velocity was u plus b. So m into u plus b is the momentum before collision from the plate's frame. And after collision, the velocity is reversed. So it will be m into minus of u plus b. So it is minus of m into u plus b. What is the change in the molecule's momentum then after the hit has happened? It is final minus initial. That is minus of twice m into u plus b. Okay, so that is what. Now if we apply, this is the change in the molecule's momentum when it hits the plate. Okay, so that is the change. That is minus of twice m into u plus b. Because minus comes up because it is being pushed away from by the plate. That's it. Okay. Now if we apply Newton's third law, because we see, imagine it goes and hits and then reverses direction. There is action and reaction taking place. Okay. So what is the molecules? What is the from the plate perspective, from the front side of the plate, what is the change in the momentum? That is equal to opposite of this minus, that is minus of minus is plus twice m into u plus b. So whatever momentum the molecule will lose, that will be gained by the plate. So what is the gain of momentum of the plate when the molecule loses this much amount of momentum? That is equal to twice m into u plus b. So, okay, so so the front side of the plate has a change in momentum from the plate's perspective to be twice m into u plus b. Now what about the back face? For the back face also I have calculated, and the calculation is like this. Okay, so in the back face, you see the molecule is going towards the left to hit this plate. So its velocity is minus u. At the same time, the plate is also moving towards the left, so it is minus of v. The velocity of the plate is minus v. Now what is the relative velocity? Relative velocity should be velocity of the molecule minus velocity of the plate. So that is minus of u minus v. The negative sign indicates that from the plate's point of view, the molecule is approaching, it is moving in the direction, okay, of the plate. That is why we have told it to be negative. Now, after collision, what is going to happen? Say, relative velocity from the back face before collision is like this, minus of u plus b, like this. And after collision, it is going towards the right. So it is to be the negative of the relative velocity before collision, that is minus of minus. What will happen? It will be plus of u plus b. Sorry, plus of u minus b. Okay. Now we have to calculate the momentum of the molecule from the plate's frame. So before collision, the relative velocity of the molecule was minus of u minus. So its momentum will be m into minus of u minus b. That is equal to minus m into u minus b. After collision, it is plus of m into u minus b. So what is the change in the molecule's momentum as it hits the plate? It is twice m into u minus b. So again, you have to use Newton's third law. We can calculate the momentum given to the plate by the collision of the molecules on the plate. Momentum given to the plate, okay, by the collision of the molecules on the plate. How much? Molecule change in momentum of the plate is equal to reverse of this, minus of twice m into u minus b. So the negative sign tells us that the plate is pushed in the leftward direction due to the collisions of the molecules to the back side of the plate. Okay, so what is the change in the back side of the plate's momentum? Minus twice m into u plus. But you see, there is one thing I have to reiterate, that pressure, is a positive quantity. So we are just removing the negative sign here. So finally, what we have is this. What we have is this. Before you, change in momentum from the front side is equal to twice m into u plus b. And we have summed up the results here twice, and change in momentum of the plate from the back side is twice m into u minus b. Okay. Now what we have to find is, the next step is very interesting. The next step tells us that in the next, how do we proceed with the next plan? The next plan is we have to find the rate of molecular collision on each phase. See, the molecules are continuously hitting the plate. When they are continuously hitting the plate, they are delivering some push on the plate, obviously. So they are transferring some momentum on the plate. Okay, so for that we need some kind of calculation, some basic idea. The idea is that, imagine the molecules are hitting, say this is from here to, say this is the plate. Okay, and from the molecule is moving randomly in all the directions. So from here to here, say the molecule takes 1 second to hit the plate. So what is the distance it will take? We know velocity is equal to, speed is equal to distance by time. Since time is 1 second, so speed should be equal to the distance. Now distance should be equal to what? The relative velocity u plus b. So that means this u plus b is a cutoff. That means any molecule which is lying within this distance of u plus b is going to hit the plate, and any molecule away from that distance is not going to hit the plate. That is, U plus B is the cutoff length at which any molecule lying within this length is going to hit the plate, and as a result is going to push the plate further. Now we know that I have told you before that if this is the plate, half of the molecules will hit from the front and half of the molecules will hit from the back, right? That means what is the rate of heating going on? For that, I have devised a simple idea. What is that? You have to find the volume at which the thing is happening. Imagine this is the plate. The plate has an area A. And if we take a cylinder, the area of cross section is A. Then what is the volume of the cylinder? A into the length, right? A into the, see, the volume of the cylinder is V, which is equal to the length U plus V, okay, into the area of cross section. We have, as I have told you before, half of the molecules, that is the density will now become n by 2, because if you n is the Lombard density of the gas molecules hitting the plate. Now n by 2 is the half of the density of the gas molecule which are hitting from the front, and next n by 2 is are those density which is hitting from the back. So now let us calculate the front face hitting momentum or the molecular collision rate. So what it will be is this. See, it's an easy question, but it is very conceptual. So what is the rate of the molecules which is hitting from the front side? It is equal to the molecular density, this n by 2 is hitting from the front side, into the volume. So the n by 2 molecules are covering this amount of volume from the front side. And what is the amount of molecules which are hitting the plate from the back? That is again same n by 2, but what is the relative speed from the back? It was relative speed from the back was U minus B, and the area of cross section remained the same, it is A. So the n by 2 molecules are covering this volume from the back side. So we have got the rates of hitting from the front as well as from the back. Now let us find the force. Please remember, this amount of molecules are hitting, and when they are hitting, they are producing a momentum on the plate. From the front side, the momentum is say R1. So what is the force delivered? The rate into the momentum delivered. So it happens to be this rate into momentum is delta P1. That value is given. We have already calculated, and the calculated value is twice m into U plus V. So twice m into U plus B. So you calculate, you get to be this amount of value. Similarly, the molecules which are hitting the plate from the left, they are delivering some momentum. Continuously, they are hitting with this rate into the, the momentum. The momentum is, as we have calculated earlier, it is twice m into U minus B. So this rate n by 2 into U minus B into A into the molecules momentum from the back side, which are, when they are hitting the plate, that is equal to this. So the amount of force which is received by the plate is equal to this. So let us convert this force into pressure. We all know the definition of pressure, right? Pressure is equal to normal force acting per unit area. These are the assumptions we have made. So the normal F1 is this, the front side, which is equal to this by A will be Mn into U plus B the whole square. Mn into U plus B. Similarly for the back side, it is Mn into U minus B the whole square. You can see clearly from the two relations that the pressure on the front side is much greater than the pressure on the back side because of this negative and the positive terms. Okay. Now you see there is a catch. Now you know why is this happening? Why is the pressure on the front much greater than pressure on the back? Because as the molecule is moving towards the forward direction, towards this direction, the molecule is coming and hitting this. So when the molecule is hitting, the relative speed increases, so they will hit it with much greater force. That is why the pressure is more, okay, compared to the back side. Now if you compute the difference of the front and the back, you get to be 4n into U plus B. That's it. Now you see n is a constant quantity, m is a constant. What changes is U and V. 4 is also constant, so the change in the momentum is proportional to U into V. Okay, so as the question says, show that the pressure difference between the leading and the trailing face of the plate is proportional UV. Leading means the front face and the back face pressure difference has to be UV. So that is what we have done. Okay, so I hope this interesting question I have solved it for you and you have understood. If you have any doubt, you can please comment. So assalamu alaikum.